Good morning, everyone. I'd like to thank the South Dakota Department of Transportation for presenting this wonderful site here for us to have our meeting. This is kind of interesting. It's something that I just kind of stumbled into. You do all these projects and you never go out and look at them. And then 20 years later, you go back and you just kind of stumble into that's holding up incredibly well. It was a pleasant surprise. So we'll get into this. This Oklahoma's 5-inch overlays on some Haunched slab spans. This is kind of what a Haunched slab span looks like. This one looks like it has some rigid frame action. It's not the ones what we did. It's just a nice picture. I wanted to show it off. So I discovered that we had put these 5-inch overlays on 21 of our Haunched slab spans, and I'm going to talk about 3 sets of twins, all on I-35, northbound, southbound, and they're all pretty much 30, 40, 30, but there's slight variation. You'll notice that the deck rating on every one of them is at least a 6, except one bridge there, it got all the way down to 5. So I'm pretty happy about that. This is the locations. We have our south location. It's, if you know Oklahoma, it's down near Ardmore. Then we have one that's 35 miles south of Oklahoma City, which I live in Purcell. That's one I've been driving over for 40 years. And then the North Bridge is near Perry, Oklahoma. So they're all on I-35. So this one has a slightly different span arrangement, 32, 43, 32, but they're all kind of similar. Built 1965. It's the newest bridge, and it also has the oldest overlay. It's interesting. There was kind of like a group of 6 bridges that were done at this time. And this is the only one that has a deck rating of 7. The others are in good condition, but not quite this good. So our overlay is 22 years old, and the bridge is 58 years old. So this gets interesting. The plans look pretty similar on all these. And I'm going to kind of make my own estimated deterioration curve. So I went through all the inspection reports, and you go back to about 1965. We weren't doing the NBI just like we are now. It's kind of like the inspection report would say good. Well, is that a 7, 8, or 9? So I kind of put something in there that kind of fit our curve. And the older inspections, they don't have an inspection record every 2 years. I found some gaps in there. But anyway, I kind of came up with this, and we came along and we put this 5-inch overlay on it, and it brought things back up into a really good condition, which I was kind of proud of that because we were getting down in the 3 and 4 range. All right, what did we do? Okay, this is one of those bridges that we put 100 pounds of steel fibers, 100 pounds per cubic yard, which is quite a bit. We did milling. We milled 1.5 inches, and sometimes, not necessarily on this one, but we have a roadway pavement that they put asphalt on it, and it's 5 inches above, so it's more expensive to remove the pavement than it is to put a 5-inch overlay, and it happened that these bridges had capacity to take the 5-inch overlay. So looking at this, you could see the steel fibers at several locations at the surface there. They rust, but they don't connect to each other, so they don't cause a whole lot of problems. We did get a few cracks, and the bridge inspector, he put this, he only rated the deck, which is a slab span, but he put it 90% condition state 1 and 10% condition state 2. So the next one is the one I've been driving over 40 years. This is the most troublesome bridge. It was built in 59, so it's 64 years old. The overlay on the inside lane has 17 years of life. On the outside lane and the shoulders, it's more like 13 years. We had a little problem in there, a little hiccup. But anyway, we'll explain. The ADT is the highest of all of them, and this is one direction ADT, 17,700, 36% trucks, and there's a quarry just way south of here, so the northbound gets some pretty healthy loads sometimes. Plans very similar on every one. Deterioration curve, it's kind of similar here. We had a little asphalt overlay, seemed to bring it up a little. Then our 5-inch overlay, which this one was sloped, so it's a variable depth, it delaminated on us. So it didn't last real well. We glued it together. We got 4 years out of it, except on the inside, we didn't have a problem. So you look at the pictures back in 2006, and it looks like a hopeless case, especially that outside lane. We kept putting epoxies in there, trying to glue it together, trying to extend the life. It was just a losing battle. So in 2010, we came in and we put this, the cross slope was 1/8 of an inch, and it just wasn't draining well. So we did this variable depth overlay. We used fibers that were 46 pounds steel and 2 pounds polypropylene for a total of 48 pounds per cubic yard. The depths varied. It got to be 5 1/4 in the middle. We also put a little bit of welded wire fabric in there, but that's all the other 2 bridges had epoxy rebar plus 100 pounds, but this one just had a little bit of welded wire. So you look at it today, when I drove over it yesterday, there's kind of in the approach slab, there's kind of a little bit of a patch, a nice bump, which I kind of hate that. And then there's a few other patches. It's holding up fairly well. You can see there that he coated the wearing surface, element 510, put it in 54% 2 and 46% 3, which is, well, maybe a little optimistic, but it's concern. This is the only one I just kind of wanted to show you, the twin bridge. It's a little bit different. We're seeing map cracking on the other side, but this one drives super smooth. I enjoy it. There's a slight bump on the outside lane at the end, but it's really a pretty good ride, and pretty happy with that. They had put it 90%, 98% condition state 1 and 2% condition state 2. So now on to the North Bridge. Again, this is a 1959 vintage, 64 years old. The ADT is half of what the Purcell Bridge was. The deck is 7, the super sub 6. You know, some of these, I don't think they used air entrainment, and you look on the underside, the soffit, once in a while you see this efflorescence everywhere a rebar is, and you look at the sides, and they look a little ugly, but the deck, if you're driving on it and you don't look under the bridge, everything looks great. The plans look similar. This is just kind of my typical deterioration curve that I came up with. Kind of went through the same process. Asphalt overlay brings it up a little bit, and then it drops. In 2004, we have a 19-year-old overlay here on a 64-year-old bridge. It came up, but this one, I did find documentation where we signed a lane in 06, and we're in the process of reapplying that silane. And there was 8 in this group of bridges in our change order, and all of 8 of them have 7 load ratings, so I think silane played a part in that. Here's our change order, the plans. It's a case where if we removed the roadway asphalt, it was just more expensive, and we decided we were more economical to put the extra thickness on the bridge, so we did that change order. The key elements here is we put in the epoxy rebar, And the Class AA concrete would probably have been 3,500 back in that time frame. It's like 4,000 PSI now. I found no evidence of hydro, but I thought some of these might have had hydro. The rating on this, the inspector had, I thought, kind of an interesting description of our steel fibers: nails, wires, hairpins. So I said, we put those in there on purpose. It's not an accident. And we don't know exactly how many pounds we did, but I suspect we used the South Bridge as a guide, and I think we might have put 100 pounds in these too, but we're not sure. We couldn't find the evidence. So anyway, the inspector said 60% condition state 1, 40% condition state 2, and 8 out of 8 were 7s, 8 different locations. So a word about silanes. They make the deck hydrophobic. The bubble is not totally round, but it's kind of flat a little bit like the middle bubble there, which makes it beat up, and it keeps those nasty chlorides out of our decks, and it keeps the water. And if in Oklahoma, our Dr. Lay, where we do this performance testing, he says we're getting 12 years. Dr. Lay has also said that silanes will seal the sides of cracks, which is very interesting. I noticed that we had always used 40% solids. If we had used 100% solids, we would have got a little better penetration. I don't find any evidence that we did hydro, but this is a more typical overlay where we did like 1.5 inches latex modified with hydro demolition. This was down south. But it shows a problem. You'll see that bottom left there, we got those rusty rebars, and the rusty rebars got so bad that sometimes in the negative moment area, our bridge inspector would want to take out the rebar completely and replace it because it was so far gone. Well, you think about that, and that's kind of taking your negative moment. If you take too many of them out, maybe you lose some of your capacity on your bridge there. So this is a concern. So we told them maybe we'll just do a 2-foot strip. Don't do more than that at once. Or then we started putting false work under them, making that a requirement. And I've been wondering if there's some way you could pull stitch in that negative moment area, especially in the curb where you have a little more section loss. But literally I came out to 1 or 2 jobs, and there'd be 4 or 5 rebar, negative moment rebar laying on the side there. So don't want to recall where they were though. So steel fibers probably aren't something you could pump too easy. Dr. Lay's done some research. He's at Oklahoma State University. He says you might consider macro or microfibers, and he's done a lot of research on these macrofibers, and he's pretty fascinated about that, and that's something you could pump. Also, there's another thing you could do that's to try to use a little more balanced concrete mix design if you had kind of like 3 bins at your plant, which he calls tarantula curve. So conclusions. Oklahoma DOT has successfully placed 5-inch overlays on 21 bridges, and your design life is supposed to be 50 years on those, so we're getting into the 60 category, and some of them I think might even see 70. So I'm proud of that. It's bridge preservation. Best surface preparation to minimize demonding for future projects I strongly recommend, if you're going to do a bridge, slab span bridge, using hydro. I think that's the way to go. And I strongly recommend that you consider sealers. And we've had a lot of success with silanes. And like I said, we're getting 12 years out of our silanes. So I'll take questions. That's my grandkids if you read my bio.